I hope that I am properly audible and visible to all of you. Okay. Good afternoon to all of you. I hope that I am properly audible and visible to all of you. So, CR, ACR, those who are viewing my session and all the students, any one or two students kindly send me a message or send me a note in WhatsApp that sir you are properly audible and visible so that I can start my session in a proper way. Okay. So, I am waiting for your response from your end. After getting your response, I will start my session in a complete way. Okay. So if I am properly audible and visible, if no lacuna are there, kindly send me a note so that I can start it and start today's lecture. I am waiting for your response from your end. Okay. So kindly send me a message so that I can initiate my lecture. Hope I am properly audible and visible to all of you. Those who are viewing, kindly text me, any one of you, any student, kindly text me or send me a WhatsApp note that sir you are properly audible and visible. I am waiting for your response from your end. Am I audible and visible properly? I am waiting for your response from your end. Okay, thank you. I got the response. Okay. So today first slides are already known to you. Okay, so today first we let complete the rest of the part of the module 1, that is the introductory part of our database management system, that is the history of DBMS and the advantages. So we already studied lots of things about this history of databases, okay, and the advantages. We already discussed the advantages and history, all these things so many times. Okay, so next, basically as we know that thing in 1950s and 60s, basically the data concept coming up with some kind of a magnetic strip. Magnetic strip is a kind of a storage where sequential input is only possible, means you can't delete the information from the magnetic tape, and erasing the magnetic tape, that is a huge costly features that time. Okay, so in magnetic tape only one by one sequential data input is possible only. Okay, no other things of concept is there. And punch card is like that employee attendance system, that in magnetic strip some employee biometric details are there. It may be considered as the punch card. Okay, in 1950s and 60s basically they are using. So in late 60s, or you may consider it in starting of the 70s, hard disk concept came up with the direct access of the data, means in real time data access we are following the hard disk. And after that the hard disk concept is further improved for the network and the hierarchical data model as well. That time basically the COD in 1970, COD defined some kind of a relational data model. So specifically this relational data model is used by all of us nowadays. Okay, so in 1970 COD defined the relational data model, and this particular features getting awarded by the ACM Turing Award, and IBM researchers also considered that thing, and US Berkeley are also initiate some process in that part. Okay, so after in 1980s, after the coming up of the SQL, basically the SQL is used for the industrial features and for the business, mainly the large segment of the enterprise. Basically for the large segment of the enterprise, SQL is that time used mainly for the commercial development, mainly for the product development, mainly for the manufacturing processes. Okay, so parallel distributed type of database systems are there that time, means parallel processing distributed concepts are there. After that we involved with some object oriented concept in SQL. So in 1990, after 1990s, there are a huge demand of SQL in everywhere. So that's why lots of advancement has been done. For example, used some large decision making or support system, some data mining concept are adapted, multi-table or multi-tier data concept. Okay, lots of things are there. And for the web e-commerce or for the web commerce purposes, we use the SQL as well after 1990s. So basically, we already covered that part. Basically, what is the advantages of DBMS over the file system? Meaning is that what is the drawback of the file system? Means the traditional file system. Okay, apart from the DBMS, what is the drawback in the traditional file system? We already discussed all this point, that is data redundancy, data inconsistency, isolation, dependency on the application programming, atomicity, lots of issues are there. If we take a formal example, that if two users are there, for example, if user A is want to transfer $100 from his account to B's account, for example, if you visit the bank, if the $100 is debited from your account or from A's account, and if the power is completely goes off and the whole system is crashed, so when it comes back, so that time it shows that no amount is credited to B's account, but $100 is already debited from A's account. So that is the ultimate scenario. This is considered as the problem of the isolation, inconsistency and atomicity as well. That the transaction is not properly completed, transaction is crashed, but we have no as such record for that purposes, but the $100 is debited from A's account. So to roll back this particular transaction and to reinitiate this process, we need some specific type of a database management system for doing that thing. Okay, these are the mainly disadvantages or drawback of the file system, and as well as data security is quite less in file system. So next we focus on the advantages of the database management system. So in database management system there are huge advantages. We already discussed that part, that no redundant data should be there, means all the redundant data that should be removed from the database as possible. Meaning is that, for example, we already give an example in in last lecture session, that for example, if you are maintaining a table, with the instructor name, with their corresponding building name, their corresponding department name, their corresponding salary and all that matter. And we all know that in an organization, the salary of the employee should, in maximum cases that is different, in some cases that may be similar. Department, some of the instructor or some of the employees maybe belongs from the same department, maybe belongs from the same building, like that. But if you consider that in a data, for example, that if you are handling a table, in this table, if you found that near about 20% of the element or 20% of the unit element, for example, any field in any of this row, if you find that near about 20%, 10% or 50% of the unit element in a particular table is similar to the other element within the same table, then we may consider that thing there is some redundancies are there. Got my point? Means as a normal situation, it's not considered as a redundancy. For example, if I say that myself belongs from the Department of Computer Science and Engineering, some other faculty member maybe belongs from the same department, that is Computer Science of Engineering. When 3 or 4 of us data are stored in a single table, so it's maybe replicated that thing, that in a row computer science and engineering department is replicated 3 times or 4 times. So if you see the whole structure of the table, then we may check that thing near about 10% of the 50% data are replicated. So our main target is that to remove this data as much as possible. So what is the solution? It's obviously not a solution that I change my department, that is not obviously that myself change my department from computer science and engineering to any other department, and no other faculty member obviously doing that. So the solution is that in that scenarios, you may divide this table in some multiple table to avoid the replicated data and maintaining the unique data as possible. So meaning is that whatever percentage of replicate data are present in your table, that is considered as the percentage of bad design or percentage of bad data are available in your database. We should remove that thing, or we should divide that thing, depend on the normalization theory. Okay, so that is the main advantages of the database management system, that no duplicate or redundant data should be there. Okay, and data consistency and integrity, we already covered that part, that data consistency and integrity meaning is that we already give an example that if user A is debited by $100, that should be reflected in the creditor account. Okay, that should be reflected in the predicted account. If no as such scenarios are there, then we may consider that thing there is a lack of consistency and the integrity. And data security, obviously there are some hierarchical concepts are there that if you are fetching the real database or the actual database, so for that purposes you have to maintain some accessibility in different layer. Okay, privacy concern is there in DBMS, and easy access of the data. Obviously easy access of the data meaning is that you can fetch the data depend on some query based processed language, and within some very specific time or very standard time you will get back your data. And easy recovery, if your database is crashed and the whole database backup is already taken care by in some other channel, so you may take care of that thing. Okay, and flexibility is there, meaning is that you can embed any SQL part, or you can embed within a C program you can embed some SQL queries, so that as an input or as an output you can directly fetch this particular result through this query processing language SQL. Okay, so lots of advantages are there. We already discussed that thing in 2-3 sessions earlier. So still from that, still there are some kind of disadvantages are there. We already know that thing, that implementation of DBMS implementation, initial implementation cost is quite higher. It's high compared to the file system. Okay, and complexity meaning is that database system are complex to understand, meaning is that it's quite complex to understand, means some procedural languages are there, some SQLs are there. And performance, obviously database systems are generic, making them suitable for various applications. However, some features are added with this database that may be degraded some performance when there are lots of applications are attached. Okay, so these are the DBMS components. We already studied that thing, that some specific data files are there, that different kind of data files, for example, that is like magnetic tape, magnetic disk, optical disk, pen drive, flash memory. These are considered as the data file. And compiled DML in the sense, for example, that data manipulation language, lots of for some specific operation like insert, delete, update, alter. So DML statement that may be processed in some specific way and that may be reused. Okay, and data dictionaries are there. Data dictionary meaning is that, for example, here it contains the information like, for example, that as the name suggests, that the dictionary have all type of data item, means everything data item that may be considered here, that is focused on the data dictionary, like table, views, materialized views, constraint, index, trigger. So data dictionary meaning is then the set of rules, the actual data, the constraint, all that things are covered within this data dictionary. These are the component of the DBMS. So we already known about this particular diagram. We already covered that thing in our earlier session. Okay, so in our earlier session we already covered that thing. Basically, these are the each and individual components of our database management system. Okay, so we already covered that part. So these are the end of the first module. We take near about 7 lectures for that purposes. That near about within these 7 lectures we already covered database user, structure, component, characteristics, architecture, lots of things, advantages, disadvantages. Moreover, all the questions that should become, we covered all those things in module 1. Now we are focusing on the module 2 part. Without wasting time, we are focusing on the module 2 part. Okay, so in module 2 part is basically the ER diagram or the ER model. So what is the full form of the ER? The full form of the ER, that is the entity relationship model or entity relationship diagram. First we study about the entity relationship model, then we are focusing on the entity relationship diagram. So what is the entity relationship model? Next we focus on that entity relationship model is a kind of a model that is connecting some constraint or connecting some rule based between the entities. Meaning is that, so first we understand that what is entity. Entity may be considered in the sense, in our world any distinguishable object may be considered as the entity. Maybe it's a tangible and maybe it's intangible. Meaning is that maybe it's has some virtual existence or may not have some virtual existence. For example, that if I say that a person, so person has some kind of a properties, so person can be considered as entity. A book that have physical existence, it may be considered as a entity. For example, a building that may be considered as an entity because it must have some features. So in our real world, any kind of distinguishable item which particularly holds some features, that may be considered as an entity. So that may be tangible and non-tangible. So if I consider as the non-tangible, so example is, for example, flight reservation or the flight tickets. Flight tickets does not have any virtual identity. So it has some features, train tickets or SMS, a banking transaction, okay, a payment order that should be generated by the Amazon. This kinds of entity that does not have any kind of physical existence but have some specific features. So now the task is that all these dissimilar or similar kind of entities can be connected in some way so that each of the entity shares some specific information to other entity sets. So when you are pushing some relationship, for example, a student is an entity, a teacher is an entity. If I am putting this relationship between a teacher and a student, that may be considered as, mentor may be considered as the relationship name. That a teacher is mentoring a student. Good. Teaching may be considered as the relation. For example, a teacher is teaching a student. Good. A teacher is guiding may be considered as the relationship. Means here two entities at both corner, two entities are same, that is teacher and the instructor of this faculty, but the relationship term is changed one by one. So teaching, mentoring, guiding, whatever, all this profession or teach, mentor, guide, all these professions are considered as the relationship. Now our main task is that we are going to create the relationship between the entities and all these specific relationships. Okay. So that is the prime target of us. So in entity relationship diagram, lots of concepts are there. We are covering one by one. First one is the design phase, data modeling is there, data constraints are there, ER diagram, design issues, weak entity, extended ER diagram, then an example of an creation of an bank database, then reduction to the relational schema, then database design, and the ending with the UML concept. So these are the specific topic with our entity relationship model. Now next we are focus on the next part, that is the design phases. Design phases meaning is that whenever you are going to create a database, for example, if I am giving you a responsibility that create a database for the university or the UEM Kolkata. So there are 2-3 phases are there. So first phase is consist of the initial phase. So at the initial phase, the first target of the initial phase is that you categorize the data, you categorize fully the data need of the prospective database user. Means in initial phase, any database administrator must check that for this particular database who are the end user. Means who people are going to check this particular database. Okay. So at the initial phase, we are taking care of that thing. So we are taking care of the prospective database user, means guess that we are going to use this particular DBMS. Good. So this particular guessing process or this particular identification process gives some idea to the database administrator that what particular data model we should choose. Got my point? Meaning is that depend on the data, if various types of data are there, if you need some filtering kind of a data, then you choose some specific data model for that purposes. So depend on the functional requirements or depend on the functional characteristics, database designer choose some specific data model, and on this specific data model comply with the conceptual schema. Meaning is that as per the SQL there are some conceptual schemas are there, that some conceptual design methods are there. So depend on this conceptual schema, the database designer focus on that part, that what data model should we choose. Next, a fully developed conceptual schema. If a conceptual schema is fully developed, then it's check that all the functional requirements are satisfied or not. Okay, and after that thing we are processing with the operation. So at designing phases, these are the initial designing phases. At the designing phases, there are two separate important phases are there. First one is the logical design and second one is the physical design. In logical design, what is our main target? In logical design, the main target is that in what actual data model we are currently working on. Meaning is that at logical design, we are checking that thing that deciding the database schema. Meaning is that at what database schema should we adapt for this logical designing purposes. So in logical designing, two sub part are there. First one is the business decision and second one is the computer science decision. Business decision will focus on that what type of record you are going to put in this particular database. And the computer science decision is that what relations are established between all these entities and within the particular segments. Okay, these are the logical design. And physical designing is that after the initial phase and after the logical design, we are going to start with the coding process, that it considered as the physical layout of the databases. Next is the designing approaches. Designing approaches is very interesting. Designing approaches meaning is that, for example, here the designing approaches are depend on two specific data model. Means whenever we are designing a particular database, we are taking care about two specific data model. First one is the ER model and second one is the normalization theory. So in ER model, that's we are going to discuss in upcoming session or in today's session as well. In entity relationship data model, basically there are two components. First one is the entity and second one is the relationship. So what is considered as the entity? A thing or object that is distinguishable in our world, that is considered as the entity. And each of the entity, for example, person may be considered as an entity. Each of the entity must hold some of the specific features, and all these particular features are considered as the attributes. Got my point? So now you note down these particular things, that what is entity and what is the attributes. Attributes are nothing. Attributes are the specific features that are provided by the university. So next is that. Next we are going to check the. After that, we are focusing on the relationship. So entity have some identifiable objects, and each of the objects have some specific rules. Okay, and next one is the represented diagrammatically by an entity relationship diagram. Means whatever discussion we are done here or whatever planning we did here, all these things should be printed, or all these things should be diagrammatically drawn on a particular page, and that is considered as the where all the entities are connected with all of their social relationships. Okay, all of the social relationships. Okay, so these are the things. So using the normalization theory, we may using this normalization theory, we may check that what is how our design are quite bad, how many facts are there, and we should check that thing. Okay. So next we are focusing on the next part, that is the outline of the ER model or the entity relationship model. So in ER model, first we understand that what is the ER model. The ER data model was developed to facilitate database design by allowing a specific specification in an enterprise schema and represent the logical structure of the data. So here in ER model, our basic target is that it's a logical structure. In this basic structure, our main concern is that some employee answer price is there, so the person is not there. Okay, so here the particular ER model, basically it's a very useful for mapping of meaningful and create some interaction about the real world enterprises using some conceptual schema. Meaning is that In ER model, basically the task is that each and every entity or similar type of entities may be grouped, and that may be considered as the grouped entity. A group of entity is connected with some other entity using some mapping consideration, and this mapping consideration is considered as the ER relationship. For example, if I say that a student is guided by a teacher, so here guided by may be considered as the mapping procedure. So in ER model, basically in ER model or ER diagram, three components are basically most important. First one is the entity sets, means what is the similar type of entities are considered as the entity sets, and relationship sets means if the different entities are connected with different relationship, that is considered as the different relationships. And apart from that thing, there are attributes. Attributes may be considered as the features. So features may be for the entity sets, features may be considered okay. So these three components are there. So ER model have some associated diagrammatic representation. Okay. So in ER diagram there are some logical structures there. Next we are focusing on the entity sets. So first we identify what is entity. An entity is an object that exists in real world that should be distinguishable and may not restricted by the physical presence. For example, is person, company, event, plant, flight ticket reservation, train ticket reservation, all that things. And next, what is the entity set? Entity set an example. For example, that entity set an example that whenever similar kind of entities or set of entities are grouped together in the same group, then it is considered as the entity sets. For example, that set of company, set of tree, set of holiday, set of pets, okay, all these things are considered as the entity set. So here you can check that thing that an entity is represented by a set of attributes. So features, meaning is that an entity is considered by their features or attributes. So here if you can check that two entities are there. First one is the instructor, that is tangible properties, and next one is the for example course. So in instructor and course, if you can check that total 4 rows or 5 rows are there individually, that is considered as the okay. So here for example in an entity set, in number of attributes, so here you can check that thing that if you read this particular slides, you can check that thing. A subset of the attributes form a primary key of the entity set. Meaning is that whatever features are available with your entity, from this particular features, all nodes should obviously not used. Meaning is that, for example, that whenever you are fetching an entity and each of the entity have 5 attributes, and from these attributes one unique attributes are considered for unique identification purposes, and that is considered as the primary key. So from group of attributes or from set of attributes, you are selecting a particular card that may be considered as the okay. So next one is the example. If you can see that thing here, you can check that thing here, that the example is quite self-explanatory, that here 2 entity sets are there. Okay, first one is the instructor entity set, second one is the student entity set. And in first one, in instructor entity set, each of the employee name is there and IDs are present. If we check through the corresponding IDs, from the first column, you can check that thing, there are no access similarities are there, and the same thing is maintained in the second. So no further upgradation is required. So same as for the student table, in student table lots of situations are same. Okay. So if I say that these are the grouped entities. For example, first one is the grouped entities of the instructor and second one is the group entities of the student. So if I want to establish any kind of a features, or if you want to establish any kind of a relation, that thing should be possible from any end. Okay. So here you can say that thing that each of the entities that are properly in two type. First one is, okay, so two type of entities are there. So two type of entities are there. First one is the okay. So in tangible and intangible properties, if we can check that thing, in tangible properties the physical existence should be there, that is car, pen, bank locker, our shirt, me, myself. Okay, and intangible means those does not have any virtual assistance as well. For example, your internet banking account, for example your bank account, flight ticket, train ticket, these are considered as the intangible entity. Okay, so these are the basics about the ear tag. Okay, so I hope that now all of you will focus on this screen and complete the quiz ASAP. Complete the quiz ASAP. I am opening the quiz link for that purposes. So if you have any question, you may ask, otherwise you complete your quiz. Okay, if you have any query, you may ask. I will discuss each and everything. Entity relationship diagram is a very important chapter. Okay. Someone is saying, sir, can you please send the module 1 module to whole PDF in your official Telegram channel again? Obviously not. I am not going to share the whole PDF anytime. For each and every day, I am sharing my class notes. In last week, one session was pending, notes was not shared. I already shared the same in today's morning. So those who are regular viewer, I hope that they have no problem regarding that thing. Those who are very pathetic listener, for example, once they are attending the session, they will surely feel some problem. So even they are not writing their name. So those who send me the name or who send me the query that, sir, can you set the module 1 and module 2 whole PDF, that is not possible from my end. I already shared that thing in your group, and after each and every lecture I am sharing the same. Okay, so not possible to do the same clerical types of work once again, because we need lots of time for some other purposes. Okay, I already shared the module 1 complete notes lecture wise. You may download that thing from your Telegram. Okay, and for module 2 I will share that thing one by one, no issues. Okay, so any other queries in this regard? I am checking. Okay, so no such queries are there. So if no such queries are there, you may go to the quiz session, or if you have any query, you may ask the query. Okay, you may ask the query. If you have any query, you may send the query, otherwise you can complete the quiz, and after that you can leave the hall. Okay. So ear diagram, basically ear diagram take near about 6 to 7 lecture, because lots of operation, lots of things are there in ear diagram. Entity relationship, different type of entities are there. We will discuss that thing in later part. Different type of relationships are there, weak relationships are there, weak entities are there. Okay, so all that things are there. It's required some lots of time for that purposes. Okay, so from next session we are focusing on the okay, so those who already completed, now go on and those who already completed. Okay, so he or she complete the quiz within time. Okay, and if you are facing any issues or any questions till now from module 1 itself, in module 1 if anyone have any query or anything, you may ask the same. Okay, I am really happy to help in that process. Okay, and for notes purposes, I have already shared the notes in your telegram group. Okay, lecture wise you may recollect that thing till now. That is today lecture number 7. Okay, so these are the things. If you have any problem or if you have any queries regarding this class, you may send me the queries. I hope that all of you enjoy the session. So now complete your quiz within time. Okay. And if you have any query, you may send me the queries. If you have any query regarding this entity or entity relationship diagram, you may send me the queries. Otherwise, I am going to disconnect the session here. Okay. You may complete your quiz within the time. The quiz link is already opened, and be sure that the link will be closed by 2. Okay. So all of you, those who are viewing my session, okay, those who are viewing my session, complete the quiz within your time limit. Okay, after that the link will be closed. complete the quiz. Okay, so if you are not having any questions, so you may complete your quiz, okay, and after that you may close your session. Okay, so I am closing my session here. Thank you.